Welcome to Steph's Academy Training Center. This is chemistry and thermal concept, the second part. So I'll start with the molar mass, which is mm. So talk about molar mass. Sometimes in fact they can ask you to define the word molar mass. So molar mass is the mass of one mole of a substance. So as you can see the definition from here, a molar mass is the mass of one mole of a substance. So talk about the number of mole. This is mole. The mole is the amount of substance which contains as many elementary entities as they are in 12.00 grams or carbon-12 isotopes. What will be of here? Okay. So now the formula for calculating the number of moles. So this formula is very important. The number of moles is equal to mass over molar mass. So in symbol, we say number of moles is equal to mass over molar mass. So where N stands for number of moles and the sign is moles. And please don't forget, we can't write moles like this. No, especially you Tonga and Bemba people, you like writing moles like this. This is the wrong one. So it's moles like this or the mole like this. Then the mass is supposed to be measured in grams. So, for example, if the mass is given kg, you're supposed to convert the kg to grams. So as you can see the mass in grams here, then mm is the molar mass in gram per mole. So, using the formula, this formula, whereas number of moles is equal to mass over molar mass, and this formula, please, you need to know it. It's very important. So, example number 1, the question reads, how many moles of potassium are there in 3.9 grams of potassium? So, as you can see, the number given is the mass now. It's the mass. So, we can use the formula. You say number of moles equal to mass over molar mass. Good. Then a number of moles, the question demands us to find the number of moles because they're saying that how many moles of potassium. So number of moles is equal to the mass. As you can see, the mass is already in grams. So I'm going to put 3.9 here over the mister, which is molar mass, same as mister. So get this number from the periodic table. So get the mass number for potassium. So the number on top for potassium. So potassium is in group 1. So as you can see, say potassium. So we get this number here on top, which is 39. So the mass number for potassium is 39. So we'll get 39 here. Then now we divide the number of moles is equal to, so 3.9 divided by 39, and the answer is 0.1. So the answer is 0.1 mole as a final answer for this question. So don't forget, the next stage you need to know the formula, which says number of moles equal to mass over molar mass. Then from there, you substitute, you check in the question, how many moles of potassium, so it means we're dealing with potassium here. So you need to know that potassium is in group 1 from the periodic table, and we need to get the mass number from the periodic table for potassium. So the final answer is 0.1 mole. The question 2 reads, find the mass of this, which is 0.2 moles of ammonia molecule. So they wanted to find the mass. So still use the formula. A number of moles is equal to mass over molar mass. So as you can see, the number of moles given in the question, which means where there's N here, we're going to put the 0.2. So 0.2 equal to the mass. Find the mass. We're looking for mass. We're going to maintain M here, mass. But if you want, you can use X. You can put X there. Then the molar mass now for ammonia molecule. So the formula for ammonia is given. So we'll get NH3 like this. Then now we find the mister. So we'll say, as you can see, we have 3 times 1. So we get the mass number from the periodic table for hydrogen, which is 1, is equal to 3. 3 here. Yeah. Okay, then again, nitrogen is 1 times the mass number for nitrogen on the periodic table is 14. So it's equal to 14. Then now you add. So 3 plus 14 is 17. So the mass here is 17. Then you can say over 1. Then now you cross multiply. So 1 times m, it's m, which is mass, is equal to, so you multiply 0.2 times 17. So 0.2 times 17. And the mass is equal to, the answer is 3.4 grams, because we're finding mass. So we maintain the sign, which is grams. We got to question number 3. The question reads, calculate the molar mass of 2.5 moles of substance weighing 100 grams. So we still need to use the same formula. A number of mole equal to mass over molar mass. So number of moles given in the question is 2.5. So we'll write 2.5 here. 2.5 equal to the mass. The mass is 100 grams. As you can see, we have 100 grams there. So put 100 there over the molar mass. Calculate the molar mass. So I find the molar mass. So we put x there. Then now you cross multiply. You say over 1. 2.5 times x to be 2.5. X equal to 1 times 100 to be 100 there, as you can see. Then say over 2.5 over 2.5. You cancel. So x is equal to, so 2.5 into 100 on the calculator, the answer is 40 gram per mole. That's the molar mass. Then we go to question 4. Question 4 reads, how many moles of hydrogen atoms does 3.2 grams of methane? So they wanted to find the number of moles. So we still need to use the same formula. Number of moles equal to mass over molar mass. Okay? So number of moles equal to, the mass given, as you can see, is 3.2. So 3.2 over the molar mass. So we need to find the molar mass here. For methane, this is methane, the formula for methane. So we say hydrogen here, it's 4 atoms times 1. We're getting this one from the periodic table. Then time equals to 4. Then carbon here we have 1 times 12. The mass number for carbon from the periodic table, which is 12. Then you add, what the answer? 16, So you get 16 here. So number of moles is equal to, so it divides, say 3.2 divided by 16. So from the calculator, the answer is 0.2 moles. The final answer. Okay, here I've just remembered that the question is crucial. How many moles of hydrogen atoms? So the keyword here is hydrogen atoms. And when check in the formula here, we have 4 hydrogen atoms. So which means the answer that we've calculated here, number of moles, which is 0.2 moles, was supposed to multiply it 4 atoms times 0.2. So our final answer will be 0.8 moles of hydrogen atoms. So that's the final answer. So the final answer here, instead of 0.2 moles, is 0.8 moles, because we have 4 hydrogen atoms. So please take note on this part.